There we go. Yes. And we are back live, ladies and gentlemen. Wednesday, March 3rd. Unbelievable. Okay. So I know obviously people are still signing into the Google Classroom, and obviously or Google Classroom into the YouTube video. And as you are, yes, please leave a comment for me. That'd be fantastic. I'm going to fill you in on what we're doing today, but then I have to give you a couple of key reminders and notices because of what I just posted to the Google Classroom not less than 10 minutes ago. It's kind of an opportunity for you all, but I will talk more about that once I actually get things going. So as people are signing in, yes, please leave a comment in the chat. That'd be fantastic. So what are we doing today? Today, I need to expand upon what we were doing with logarithms and exponentials. I need to remind you of a couple formulas. I'm going to throw quizzes at you early so that we have the opportunity to review certain problems on it. And then with whatever time we have left, I do have a couple of additional pieces of information about exponentials that I am going to throw at you. I feel like these people in the next classroom over are having an argument. Do you see them? Doesn't it look like they're having an argument? I don't know. That's kind of crazy. Sorry. People in the chat are like, what is going on? And I'm like, well, it is what it is. Okay. So first. What I just posted in Google Classroom. If you haven't seen it, which again, I just posted it less than 10 minutes ago, is an opportunity for you to earn some points back on the most previous major. In the past, some people have contacted me about opportunities for retakes and things of that nature. And yeah, we do have a retake policy, as I've stated from the beginning of the school year. It's not something that I advertise, but it is something that if you ask me about, I try to make certain accommodations for. Now, there were several requests in regards to the most recent major that you guys took last week. And I wanted to create an opportunity to earn those points back, and I have. So if you are someone, now again, this is completely voluntary. You don't have to do this. But if you are someone who wants to earn points back on the previous major that was taken in this class, then you can follow the directions that are listed out in Google Classroom. It is the post that I titled, there it is, Attention Algebra 2 Students. It was posted today, roughly 15 minutes ago. So again, a reminder, if you want an opportunity to earn points back, there is your opportunity. The directions are outlined directly in that post. If you have any questions about that, of course, as the post says, you can email me. Next. As I said, I wanted to remind you of a couple of things before we knocked out said quizzes. I wanted to do the quizzes early so that we had an opportunity to review some of those questions and to build upon the previous information that we've been doing with exponentials and logarithms. So if you would temporarily, because you probably need it for the quizzes, I'm going to need those notebooks out and open. We're going to do a very brief reminder in our notes, and then I want to knock out that quizzes. Again, if you haven't left a comment in the chat, please make sure that you do so. I do see 1, 2, 3, 4, 5. Well, that was retracted. 6, 7, yeah, so I do see a bunch already, which I will have for my records. Very brief set of reminder notes so that we can get to this quizzes. I mentioned it on Monday, didn't have an opportunity to get it done. I wanted to wait until after we talked about what we needed to talk about today before I assigned something in regards to this chapter. But here we go. Today is the 3rd. I'm going to call this exponential / logarithm word problem practice. Now, this title is going to come into play not only for the reminders that I have for you right now, but also for the quizzes that we are going to be taking. What is going on here? There we go. I was just making sure that this thing loaded properly. There we go. Boom. Okay. First and foremost, these two little gems. Y equals a parentheses 1 plus r to the x power, and y equals a parentheses 1 minus r to the x power. Come on, this thing. There we go. That's weird. I'll have to fix that later. Anyway, these two formulas are typically used with word problems when they give you just enough information to get them going. For example, A being the initial value, the amount that you are starting with, Y being the resulting value, the value that you end up with, R being the rate, either the rate of growth or the rate of decay. Now, I do have to move it over for those who are in the chat because, again, the glare is there. I just want to get that over there. There we go. Hopefully they can see that a little bit better. They kind of can. It's y equals right here. The glare is like right here now, but it's y equals. Now, if you have a growth, then clearly you are going to be utilizing a 1 plus r. If you have a decay, you would be utilizing a 1 minus r. Ms. Markey, which one? It depends on the context of the problem. Do not forget, r needs to be written as a decimal. So if it's 50%, you have to put it in as 0.5. If it is 2%, you have to put it in as 0.02. You have to do that conversion to use these formulas properly. On this quizzes, there is also some exponential and logarithm type problems. Those logarithm problems, you would have to utilize the relationship between y equals b to the x power and log base b of y equals x. You would have to utilize those particular formulas. As a reminder, in your Chromebooks, you have a calculator that can get that done for you, that logarithm calculation. If you have a problem that looks like exponential form, you can convert it to log form and then have the calculator get it done for you. I'll show you on the calculator again where it is. We wrote that down last time. But again, I want to remind you before this quizzes. You would utilize log form if you were solving for the exponent. You would utilize log form if you were solving for the exponent. You don't have to use log form if you're not solving for the exponent. So please be mindful as to when you need to use that logarithm form. Finally, before this quizzes, I want to show the calculator just as a reminder if you needed to use it in terms of utilizing logarithms. You do have this TI-84 calculator going on here. So, for example, I don't know, 3 to the 2.5 power is equal to this decimal. Actually, no, I don't want to do that one. I'll do something different. Let me write it up on the board, and then I'll go back to the calculator. I'll do something slightly different from there. Let's say that I have 3 to some power equals 33 or some junk like that. And then if I were to convert that to logarithm form, this would be log base 3 of 33 equals x, because logarithms allow you to get the exponent by itself. If you hit math and go down to option A entitled log base, it allows you to type in the numbers into the appropriate location to get that answer. And then 3 to that decimal power will give you 33. Okay, hold on. 3 to the 3.182658339. Yeah, gives you approximately 33. Obviously, there's a bit of rounding error. Instead of that, you could, and I'll just bring this back up real quick. If you have that log-based thing that does work, I did also show you a way of utilizing this log button on the front of your calculator to get that same answer. So please make sure that you are utilizing where that function is if you need to use it. And that's a big if, because you don't need logarithms every single time. You only need them if you're solving for the exponent. So, if you would, I'm going to need you to go to quizzes. Going to set this thing up for you. Boom. Joinmyquiz.com. I found something out. If I actually make this like full screen, the people in the chat can actually see that number. See? Yeah, there they are. I'm going to type it into the chat regardless. 530400. I need you to get them Chromebooks out and logged on and, well, as quickly as possible. Let's get them done. I won't start this thing for a few minutes. I would strongly suggest having your notebooks just as a reference for some of these problems, if need be. I did give you those reminders at the beginning. After the quizzes, I would like to review certain problems with you, but obviously, I want to take this quizzes first. There's supposedly 11 in the chat, and there's 7 here. There are a bunch of you who are already logged in, obviously. Just like names popping up as I was walking around. Stupid Chromebooks take a while to load sometimes. Five three zero four zero. Yeah. If you have not logged in yet, the game does allow you to log in after it's started. So please, I need you to make sure you are jumping on that. There are clearly not as many people in this quizzes when I compare it to the number of people in the classroom and in the chat. In fact, of all the people that are telling me that they're here today in the chat, I don't see all of those names in this particular quizzes. I find that suspect. I find that very suspect. Just saying. I don't know. Obviously, I can walk around and I can see all of you guys on your computers in the classroom, but oh, those people in the chat. Oh, I'm going to get this thing started. If you haven't joined that quizzes, make sure that you have.
actions. Rich, the HVAC guy, please report to the main office. Rich, the HVAC guy, please come to the main office.
I'm going to give it about one more minute, and then I'm going to shut the game down, and I'm going to look at the questions that gave us the most issues. So if you're still, obviously there's still a bunch that are still finishing up. I'll give you about another minute to get that done. All right, I'm going to end it there. Click. Doom, 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 doom. Let's see what we got here. Questions. And serpent accuracy. Excellent. Let me start down at the bottom. Nice. Okay. Let's start with a problem like this. Now, what I'm going to do is I am going to pick certain problems. I'm going to specifically start with the problems with the least amount of accuracy. And I want to work my way up from there and kind of give you some certain insights into how this thing is actually happening. So, problem from the quizzes. This is the quizzes part of the review. Quizzes, if I could spell quizzes today. Yeah, quiz is review portion. The problem that I'm writing down is f of x equals 300 parentheses 1.16 to the x power. And they want to know what is the rate of growth. Now, for a problem like this, immediately, there are a few different things that I need you to recognize just by looking at this equation. First and foremost, it is in the form of y equals a times b to the x power. It is in that form. It is in that form. Not only that, b is equal to 1.16, which is greater than 1, making it, as the problem stated, a growth. Just a few little details that we can put into this. The fact that the b value is greater than 1 indicates that this is definitely a growth and not a decay. But the question wanted to know what was the rate of growth. The other form that you need to recognize is y equals a times parentheses 1 plus r to the x power. That's the other form that you have to recognize. Because 1 plus r, in this case, is equal to 1.16. They want to know what is the rate of growth. The rate of growth in this case is just 0.16. Technically, the 1 plus r, the b, does have a different type of definition. Technically, it's known as the growth factor, but that's semantics. The fact that the problem wanted the rate of growth is what makes this answer equal to 0.16. You can see that right there. I can see 6 of you did choose 1.16. But again, these are the different components of that exponential formula, of that exponential equation. 300's the initial value. X is the time unit, whatever that's measured in. And inside the parentheses, yes, that's your b, but when they want the rate, it's actually 1 plus r. So we do need to recognize these different forms. Scrolling up a little bit, I'm going to write down this next problem. Let's see here. And then I'll flip my camera back. The next example, 5 to the 2 minus x power equals 1 over 125. There we go. And I see you guys in the chat. It's okay. It's just a practice problem or a practice quizzes. The point of the practice is we get it wrong the first time and we learn how to do it correct the second time. Now, this problem is a similar problem to what we did in the last couple of class periods. But you need to recognize something. 125. 125. You need to recognize what the heck 125 actually is. If you break down the number 125, if you break it down, it doesn't take that long to figure out that 125 is actually 5 cubed. So I've got my calculator. I'm going to zoom in right there. You can see that 125 divided by 5, divided by 5, divided by 5. It's actually 5 cubed. Knowing that 5 cubed is 125. Now, not a lot of people know that off the top of their heads. They don't, which is why it only took me a few moments to figure it out via calculator. But knowing that it's 5 cubed, I can rewrite the problem like this. Now, not only did I change the 125 to a 5 cubed, but because it was in the bottom of the fraction, I needed to take the reciprocal, which forced the exponent to become negative. This is a property that we've been focusing on the last couple class periods. Because of now the relationship being the fact that the bases are equal to one another, if the bases are equal to one another, then I could do something like this. And now that is the brand new problem. Oh no! That is the brand new problem that I have to solve. So number one, 125, it only took me a few moments on the calculator to figure out that that's 5 cubed. It's in the bottom of the fraction, so I'm going to have to take the reciprocal, which forces the exponent to become negative. Because the bases are equal to one another, I can set the exponents equal to one another. And now it's just a matter of solving. I can subtract 2. I can divide by -1. And I get an answer of +5. Subtract 2, divide by -1, you get an answer of +5. I'm going to check the quizzes in a moment just to see what most people picked in regards to this problem. Okay, most people picked the answer 5/3. 6 people entirely picked that problem. Or that answer, I should say. That's interesting. I can see where some people might have gotten -1, where they made this a +3, and then they tried to solve it from there, a +3 exponent. But yeah, the 5/3, that's throwing me for a loop. That's okay, though. Like, I'm hearing like a whistle or something like that, like a referee's whistle of some video that somebody's probably watching on their computer when they should be reviewing this information. I can't tell you how much that irks me. But I'm saying it with a smile, which kind of makes it unnerving. Anyway, back to this. A car is valued at $22,000. I'm going to write down this information, then flip my camera over. Car is valued at $22,000, at a fixed rate, and it depreciates at 9% per year. After how many years will the value have depreciated to $9,000? Oh, let me write down this. There we go. That's all I need. Flip. That's what I need to solve this problem. That's what I need to solve this problem. Let me double check those numbers. 22,000 is what it's valued at, 9,000, and then 9% per year. Yes. The car is valued at $22,000. That is the initial value of the car. They say it depreciates, which is a decay. It depreciates at 9% per year. Thus, inside the parentheses, I had to do the 1 minus R because it was a depreciation. At 9%, I have to write it in as 0.09. They want to know how long, in this case, that is the exponent, that's the time unit, how long until the car reaches a value of $9,000. In order to solve this problem, the problem does suggest using logarithms. Yes, you will have to use logarithms, but you do have to do one extra little step at the beginning. At the very beginning of this problem, I have to divide by 22,000. Now, in my calculator, let me just kind of show you what it looks like here. I'm going to have to divide by 22,000, but let me show you a little trick here. I'm not going to write down that decimal. I don't feel like writing down that decimal. I hate that decimal. Instead, I'm going to turn that decimal, math, enter, enter, into a simplified fraction. You can do that with most fractions, not all fractions, but with most fractions, you can reduce them down like that. So instead of writing down the decimal, I'm going to write down the fraction 9 over 22 to make my life easier. So I'm going to divide by 22,000 to start this problem. 9 over 22 equals something to the x power. There it is. Just simplifying the inside of the parentheses. Just simplifying 1 minus 0.09 to get 0.91. You don't have to do that, but it makes your life a bit easier, again, in the long run. Now is the time for logarithms. Ms. Markey, how do you know? How do you know that this is the time for logarithms? Because the only thing preventing me from getting the exponent by itself is the base on the exponential. Logarithms and exponentials are inverse operations of each other. If I were to convert to log, it would look something like this. Because logarithms allow you to get the exponent by itself. The base on the exponential is the same base on the logarithm. I'm going to go to the calculator on my computer in a moment, and then I'm going to do the same calculation on this TI-83 as well. But I'm going to have to type in the logarithm as I have it written down on that page. Let's see what happens. Wait, there it is. Math, log base. You guys do have that on your calculators, right? Cool. Just making sure, because I know you have like the 84s, on your computers. Kapow. 0.91. A fraction 9 divided by 22. Everything looks good. Just double checking that all my numbers are as they should be. Pow! There is the answer. X is approximately 9.48. I'll round it up to 9.48. We'll have to put units on it in a moment. We'll do that in a moment. I just want to show that that answer is what it says it is. Let's flip back to this, and I can show you that if you do the calculation using that formula that I taught you last time, this change of base formula, because this 83 doesn't have a log base button, but you do get the exact same decimal, and that's what matters. Getting that particular answer. But what is it measured in? If I go back to the quizzes, it's a fixed rate, and this is a little hard for people. Oh, there it is. It's a little hard for people to see possibly on the live stream because I think the glare might be right on. Oh, no, it just missed it. It's 9% per year. And because of that, you got to put years as the unit on there. It looks like the answers were across the board even. I see 4, 2, 3, and 4 in terms of the distribution. So it just seems like either, well, most people were probably just guessing that thing. Let me show you one more thing on the calculator. Check this out. Zooming in, zooming in, zooming in. Check this out. Some people do prefer doing it this way, although it does take forever. Give me a number smaller than 7. Okay. After 4 years, the car is worth $15,000. Second enter. After 5 years, the car is worth $13,000. Second enter. There's $12,000. Second enter. There's $11,000. Second enter. There's $10,000. Second enter. There's $9,400, which I needed to get it down to $9,000. There it is. It's below $9,000. Because of this, let's see if we can get a dry erase marker here. Here we go. Because I like drawing on this. Because of this right here, I can say that between 9 and 10 years, it's between 9 and 10 years if I had to estimate an answer. Between 9 and 10 years, will it drop to $9,000? But as I've stated in the past, there is your exact answer. The exact answer is preferable, especially when it comes to problems like this. Let's see. There's one more red problem on here. Okay, yeah, we'll do this red problem. We'll do this one more red problem, and then I have one more thing to show you before we call it a day. I'm going to set up an example here. It says that 20 years ago, Mr. Davis purchased a home for $160,000. Since then, the house has increased in value. Another word for increasing in value is appreciation. It has increased in value at 5% per year. How much is it worth today? I'm going to highlight something here. 20 years ago. 20 years ago, he purchased the house, which means 20 years have gone by. Logarithms are not needed for this problem. Logarithms are not needed for this problem. How do you know? I'm not solving for the exponent. You only use logarithms if you have to solve for the exponent. But since they've given you the exponent, you do not have to worry about it. The variable of y is the resulting value. Simply put, I believe that all I have to do is type this information in exactly as I see it on the page, and it gives me an approximate answer of $424,527.63. I'm going to double check that against the quizzes in a moment, just so people have an opportunity to write that number down. That's a comma in the middle right there, and then the decimal point for 63 cents. But after 20 years, if it's increasing at 5% per year, that's the value of the home. Do you guys know what, in Brooklyn, do you know what a brownstone is? Yes. Yeah. They look like townhouses, but they're like much sturdier. They've been there forever. They're all lined up in a giant row. They kind of look identical, but they're not. They usually have like a little walkway to go like into the house from downstairs. And then they have like a stoop where you could like walk up and enter like the main part of the house or whatever. They're huge. They are huge. They're thin, but they're huge. And they're like 4 stories or 5 stories. Well, not stories, but like have 5 levels sometimes, like a basement and then like a sub basement and then like a regular basement and then like the regular. It's crazy. And then a backyard. Like it's insane. My uncle in Brooklyn bought a brownstone in 19, I can't remember exactly the years, early 1960s. But he bought this brownstone for like less than $100,000. Do you know what brownstones in Brooklyn are being sold for nowadays? Yes, it's in the millions. Isn't that nuts? Just saying. Who would have thought? Brooklyn. I'm just saying, because like Brooklyn, my family came from Brooklyn, and well, my parents left Brooklyn in 1981 because New York was getting really bad, and then all of a sudden, 40 years later, Brooklyn's like on the rise. Who would have thought? Anyway, I get an answer in the chat, and she says no, don't know what a brownstone is. Anyway, here's the quizzes. Boop, there we go. There's the answer. $424,527.63, right on the dot. Yeah. Oh, holy crap. 6 people chose that answer. 6 people chose the wrong answer. I think I know why. Yep. I know exactly why. Look at this. What's the difference between the top calculation and the bottom calculation? What's the difference? What does that mean? Exactly. The top one is 5%. The bottom one is 50%. You have to be careful with how you put these decimals in. You have to. That's a huge stinking difference right there. Okay. One more thing that I want to write down. I want you to have the following formula because I am going to be focusing on this formula next time, but I want to make sure I have it written down before we leave. I have to explain a little bit about this. When you have a bank account and you earn interest, I don't know how many of you actually have savings accounts. Good for you if you do. How often does the bank send you a statement? They're not obligated to send you a statement, but they do. They send you a statement. I have a paperless with TD Bank, so they send me an email. They send you a statement typically once a month. And the reason for that is because they issue you interest, money, and they want to update you on where things are. The thing is, banks typically have annual interest. So how are they doing this monthly? Well, they found out that you earn slightly more interest if they do something called compounding more than once a year. Most banks offer compound interest monthly, meaning at the end of every month, the computer formulates, okay, how much interest do we owe them? Boom, hand them out the money. At the end of the next month, boom, hand them out the money. And then the compound interest builds from there. Some banks don't compound monthly. Some banks compound daily. But even if they compound daily, they don't actually issue the money, the interest to you until the end of the month. Some certificates of deposit, some CDs that you get through banks, they compound interest quarterly, meaning once every 3 months. And, it depends on the bank, but some of them do compound annually. But the banks use a fancy, fancy formula. And here is that fancy, fancy formula that I need you to write down. There it is right there. This is the compound interest formula. And yes, I tried to make that look like a 1, like a fancy 1. This formula is almost exactly the same as the other formulas that we have been using. Notice the use of 1 plus. Notice the R. Notice the exponent. The P stands for your principal amount. Your principal amount or your initial amount. R is still your rate. If I could spell annual today. Usually an annual amount. That says annual. I'll rewrite that. Annual. There we go. T is time measured in years. And A is the resulting amount or the resulting amount of money. The only thing that is brand new to you is this letter N. And the only thing that I'll say for now, and we'll get into the details next time, N is the number of times compounded per year. I'm going to wrap it up there. We'll pick up with this next time. Make sure you have that statement written down. I'm going to zoom in a little bit on that. N is the number of times compounded per year. If you have not left a comment in the chat, please make sure that you do so. Make sure you are reading my statement on Google Classroom. It is to your best interest. And I'm going to sign off from there.